Okay, so for today I was thinking to get my ds.h library working with WASM and potentially with Arduino if we have some extra time, like bonus points at the end. But for now, let's just try to implement some really small game in WASM that's going to require some lists or some data structures, and we are going to try to compile, like have an implementation in C for like something really simple, like creating squares or something, and then compile that to WASM and then loading it in some really simple JavaScript. Like I'll try to have as little JavaScript code as possible and try to put everything or almost everything into the C code. So I think that would be pretty interesting to do. And I think the challenge would be because we need to compile without standard library to compile, C code to WASM, just because I want to use Clang and I don't want to use those, fancy JavaScript libraries to have stdlib. I don't really care about that. I just want to have things as simple as possible because, if it's simple, it's gonna work on pretty much anything. So we don't have to worry about it. Okay, so first step, as usual, now that I'm using Nix for like 1 year, I mean, it's not a new step, but yeah, we'll do a flake, right? And here I would have to, I mean, usually I just overwrite this file with something like a flake from another project. And since I use mostly C, this is just, always copy pasting it. But maybe just change the description to my C WASM project or something. And the only difference is that we'll need a Node.js for npm or, whatever package manager you want to use for Node. And we'll also need LLD, which is the linker for LLVM. I think it's for WebAssembly, right? Being able to compile to WebAssembly. Yeah, that, or at least this is what I needed when I did my testing or prototyping project. Anyway, so now that we have these things, let's just start a shell with these things, and let's see what we need to do next. So obviously we need to install some dependencies like Node.js dependencies, but for that we need to init a project. Although it's like, okay, let's keep everything, we don't really care about these things, and let's install some dev dependencies. And the dev dependencies that we are gonna need are, I mean, it's not the best order, but you get the point. It's Webpack, and you can think of Webpack as a build tool, which is quite interesting. It's a build tool for JavaScript, and you write the code, like you write the compilation steps, or it's not really compilation, but you get the point. You write the build things, like the build commands in JavaScript, which is pretty nice, right? You use the same language to write the make file, kind of. So that's what Webpack is going to be used for. And then we'll need TS loader to be able to load TypeScript files, because I want to use TypeScript, even though it's going to be like hopefully 10 lines of code. And HTML Webpack plugin to be able to load HTML files in case we'll have like an index.html, something that we need. And I mean, prettier just for formatting, but I guess that's all we need. So let's let npm install all of these things, which was instantly almost. That's nice. And I know, I'm using Nix, but then I don't install the npm packages with Nix. Honestly, I don't really care. I don't really know how to do that. And on top of that, I feel like some things belong to the flake.nix, like native build inputs or whatever. But if you go like so far as to put your npm dependencies into the nix file, it's kind of meh, because at that point you can only run this project on a nix, or like you need to have at least the package manager installed, right? You need at least nix to be installed, which I think it's kind of meh, because if we have this package.json, anyone can install. I mean, there are dev dependencies, but you know. Anyway, so next step would be, I guess, to have tsconfig, prettier config, and whatnot. I mean, I already have those things because I was testing. Let's just copy paste. I mean, let's copy paste all of those you know, config files, and maybe just look a bit into them, just in case interesting, but probably not really. I mean, tsconfig is just the default one. You know, like look into src pretty much to have like lsp. Then prettier config. I mean, come on, who doesn't have threading commas, who's using tab width smaller than 4? I mean, that's weird. If you use tab spaces of 2, that's crazy. And I mean, 8 is a bit exaggerated in my opinion. Like 4, it's good. 8, sure, makes sense, but come on, 2 spaces, that's crazy. Semicolons, I mean, if you don't use semicolon, that's insane, even though it's JavaScript. And then single quotes, it's ugly. Like just using single quotes, it's ugly. Okay, now that we got the formatting out of the way, let's look at Webpack. Right, so the main config for Webpack, it's, I mean, pretty standard. It's just looking for the index.ts file, and it's going to compile it, transpile it, whatever, to index.js in the dist folder. Then I'm gonna have an index.html file, which is like the main page that you open. And then we'll have a main.c file that's gonna contain the WASM code, right? So we are gonna probably include ds.h into this file and compile it to WASM. So that's the plan. And I had to write my own Clang plugin. Basically, this is just going to run the Clang command, right? And you can see the target is WASM32, and it's no standard libraries. So we'll have to make sure that it's going to compile without standard libraries. Okay, and then some, you know, extra stuff. I have no idea. I just copy pasted them. I guess this is just, you know, use ts loader for TypeScript files, and then we have the dev server, so we can hot reload, and it's, you know, nicer to use. Okay, so for package.json, I think we can use some commands, like for instance build, and here it's webpack, and we pass the config to webpack config.js. So we have the config. Then we also have serve. This one, I mean, makes sense. And let's also have format, because I mean, if we install prettier, it's like, I mean, just use, and we'll need to pass all the TypeScript files. So all the TypeScript files from src, and I guess we can even do the HTML files that we'll have in src. HTML, and maybe like webpack.config.js. I mean, all the config files that we have in here. Okay, let's just test that. Let's make an src folder, and if I do npm run format, obviously we don't have any files, but if I do index.html and index.ds and main.c and I run format, you know, it's gonna work. Okay, I guess I could also include yeah, whatever, let's just keep it like that. Perfect. So what would be now the first, I mean, now we can actually start doing some stuff. What would be the first step? Well, let's create our, let me see if I have, I don't have snippets, but it's fine. Okay, so we have some HTML and let's have like a header, the title, and maybe let's call this one example. Okay, and usually I have this viewport content and then width equals to device width and initial scale 1. I think this makes it like work with mobile or whatever, but you know, it's like the usual suspect here, and then an empty body, and maybe we'll have like a div in here with some ID like root or something, and for this div we are going to put our app, right? Like we're going to add some things in here. Maybe it should be a canvas or something, but you know, we'll see. Okay, so in the main file, in main.c, I mean, we could implement some kind of function that we are gonna test with. Maybe it's gonna be like sum of two numbers, and let's also implement it. So int a, int b, and it's going to return a plus b, right? So that's gonna be like a really simple main file, like C file, and you can see it doesn't have a main, so it's not going to work by itself. It really makes you see that, okay, this thing needs to be compiled to, you know, some kind of DLL or something like that, right? So it's not going to be an executable. And then in index.ts we need to load this WASM file and then to call the function. So usually I would have here like a what can we call it, like the WASM module, which, because we use WebAssembly, we need to define the, okay, we need to put the types, I mean, and initially it's gonna be null, right? But we'll have to do something like WebAssembly, WebAssembly.instantiate streaming, and we need to fetch main.wasm, right? And I think then we need some, so if we take a look at the function definition, it needs some kind of module, right? It needs the module, and I think fetch is it returns a promise. Okay, so yeah, it needs some kind of module, right? and then it needs some environment or things like that. And usually in the environment I put the memory, and you can also define functions. So we'll maybe see that. I'm not sure if we'll need any functions, but we'll see. Maybe for printf and stuff like that. But yeah, we need to define env, and in the env we'll have like memory, new WebAssembly dot memory, and initial is 256, let's say. Okay, and in this env you can also define functions and whatnot, and they're gonna be used. So for instance, if we go into main.c, if I would define here another function like test, which gets a number and returns a number, you can see it's not implemented anywhere. So I could come here and define test like this, right? So that's the idea inside of this env argument. Okay, and this instantiate streaming is going to return a promise as well, so we have to await it. And I mean, we do that with a then here, and we'll get a value, which, if you think about it, this value is the WebAssembly module, right, that we have here as well. So we can do something like w is equal to value, and now we have w instantiated, and we can do stuff like sum is gonna be the function, right? So we take instance dot exports dot sum, and here we don't have completion because yeah, it's like some kind of value, and it's the value, and we can just console.log sum 1 and 2, and here is going to, you know, TypeScript is going to complain because it doesn't know what's that sum is a function. It can be like literally anything. So let's define a type. This is, you know, just for TypeScript, just because we are using TypeScript. So I'm gonna say sum function. A is a number, B is a number, and it's a function that returns a number. So here I can say something like as sum function, and now it should be okay. So if we say now npm run serve, it should compile everything. All right, and if we take a look here inside of this, we have main.wasm. That's the only thing that got compiled. Run, let's run build just to, now you can see that we get a few things inside of this. Let's check them out. So we have index.html, which is just the HTML file, but you can see that now it also includes this script, which is kind of interesting. I don't know what differ is, but whatever. Okay, that's pretty nice. And then the JavaScript thingy. Again, I don't know. It's just whatever. It's just running some stuff. Okay, whatever. So let's go back. Let's run npm run serve. Although maybe I want to run it in a third terminal just to have it, you know, because if we need some command, it's easier to have it on the second one. So let's go to localhost 8080, I guess. And if we take a look at the console, we get a 3 here, which comes from this call to the sum, right? So we basically get this thing right here. Okay, so this one looks but let me just have git init, and let's add, maybe I want to also do a git ignore. Or maybe even better would be git ignore for node. And if I go here and I do I think I have to use -o git ignore. No, I think it's something else. I think it's capital O. Yeah. Okay, perfect. So now we have git ignore for node. And I'm gonna call this one initial commit. So yeah, we just saved our initial state, right? So we have this sum function, and we call it from index.ts, right? So we call our C function. Maybe one more thing we can do before now going to actually include ds.h is to use this like a print function, or maybe we can let's call it print number or something. Print number is going to be integer here, and it's going to be an a, and maybe we want to do something like int s, print number s, and then return s. All right, so we also call to an external function. Right now, if we try to compile this thing, so I mean it's it's not hot reloading it though, as I thought. Yeah, I mean that's a bit interesting. GitHub. Because I have this Tetris whatever, Tetris bits C, and I think this was the one implemented with web. Not really, this one was without webpack. I was like, I'm pretty sure I did one of these projects. Okay, now it complains about print number, but why doesn't it reload automatically? That's a bit weird. npm run, let me just run build. Okay, like, yeah, it makes sense. It's going to compile, obviously, but it's not gonna work at the runtime. Okay, fair enough. Right, at least that's what I'm thinking. But, you know, whatever, is not really important. So we have this, we need this print number function, right? That's what we need to implement right now. So as I said, we need to go to this index.ts file and add it here. So print number is going to be a function, so it needs a number, and I guess is going to be a void function, and it's going to return void. And this thing is just going to be console.log, maybe the number is, and then we just put the number here. So let's see if it's okay. So it recompiles it. Okay, perfect. So it says the number is 3. Nice. All right, so that's how we define functions that are used by the C code as external functions. So maybe it's going to be useful for things like getting access to the memory or something. Yeah, I don't know. Okay. Oh, yeah, and by the way, it was actually in the A star WASM project, the webpack config and everything from here. So that's where it was. Yeah. And this one is using an older version of ds.h. I think it's almost the original one. So it worked in WASM, but now, it obviously doesn't work anymore. And this one was using an allocator. And the allocator was actually implemented in JavaScript. And the difference now is that I have it implemented in C, so I want to use the C one. I'm curious if it's gonna work. Okay. So initially the allocator is null, and the way I think I want to do it in the same way. So we have this memory, which is new assembly, WebAssembly memory, right? Initial whatever. And here we are defining the allocator here. So I might want to somehow take this memory, the WebAssembly memory, and give it as an argument to the C code. So that's gonna be interesting how that's gonna work. So here we were defining the allocator. Here it wanted the memory and the heap base. Right, so heap base is basically the initial pointer. Okay, let's for now go to src and wget ds.h, which is the latest one. Okay, perfect. So if we come here and say include ds.h and maybe define ds, is it ds now stdlib? Yeah. Okay, and if we define now stdlib, we need to use either arena allocator or list allocator. And I guess we can use list allocator, doesn't matter. Define list allocator. And now it should be okay for some time. Let's see if it's going to recompile. Okay, so it's still compiling. That's nice. But how can we, now that's the interesting part, how will we be able to use this memory as the memory for the allocator? So allocator needs the beginning of the allocator and size. Okay, makes sense. So what I'm thinking is we'll have a main function, or at least we'll call it like main function. Let's call it entry point or whatever. So void entry point, and this entry point function is going to take in these things. So it's going to take in the start of the memory and how big the memory is, I guess. All right, and that's that. Okay, let's remove all of those other things. So now if we go to index.ts, we don't need print a number anymore. But what's interesting is we have this void pointer, right? Which is the same thing as, well, we'll need to pass in heap base. And I'm pretty sure that we can just pretend it's a number in the JavaScript world. So if we go, for instance, to the C code in the A star project, and we take a look here, you can see that malloc, realloc, those things return void pointers. But in here, where I define them as environment, I use number because it's the same size of. So we can just pretend that this is a number and this is also a number and it returns void. So if we go to index.ts, we need to change this to entry point function, and it takes in, I guess, how did I call it here? It was here. So heap base, I mean, let's call it memory, and size, and it returns void. Okay, so here we have that. Let's call it entry point, and we call then entry point, and we'll need this. Maybe let's have const memory is equal to, right? And let's have const size is gonna be a number, and it's 256 or something. Memory size, right? And instead of using this number here, we'll just say here memory and memory size. So now we have the entry point takes in like a reference to the heap start, right? And how big the memory is. Now maybe we should be able to define the memory allocator. So ds list allocator, we'll have an allocator, we'll start with 0, and then ds list allocator init, we'll give it a reference, we'll give it a memory and the size. It's kind of cool. Okay, so if I just run everything, it shouldn't crash or anything. Okay, interesting. That's kind of cool. I guess the only thing that we might need are some kind of functions that will draw something. Right. So maybe I'm gonna, look into here. So here I had render world, which is function here. Yeah, so this render world looks for the root element. I mean, I guess here it creates the root element inside of the body, which I guess it's a fair point. We don't even need that. We can just have the body here. Let me just format. Right, so we don't really need that. But what would be even cooler is actually having the canvas created in HTML and then from the C code to call to things like draw, I don't know, here there were some lines, like draw circle, draw square. Would be cool to have those functions defined. So let's actually have a canvas here. And yeah, it shouldn't matter that much. Okay, let's just maybe do it like this. So in index.ts, let's have the first thing that we do is that we create this element, right, the root. Then we create a canvas, and maybe the canvas is gonna be width 800, height 600, right? Basic Minecraft stuff. This can be const. Okay, we open the canvas and we should be able to have a function for drawing. Maybe let's do a function here for drawing a square, something. Draw square, right? Or draw rectangle. So this one should be, I'm thinking the center or x, y are numbers. And then width is another number and height is another number. So it's a function that is going to return void. All right, and here we should be able to define it. Actually, oh yeah, like this. Okay, so now it's a function that should draw a rectangle. How can we draw a rectangle? So fill rect, we need a ctx. How do we get the context? Should I create a context here? or should I create it somewhere else? Okay, so let me const canvas width is gonna be 800, canvas height is gonna be 600, and canvas width, canvas height. Okay, maybe this one is actually a function that we also have here, like clear canvas, and it just calls to clear rect. Do I have no idea. Wait, am I? Oh, you have to. Such a weird. Okay, whatever. So this one does a clear rect. That's how we draw that rectangle, and maybe here there should be another fill rect. So I would assume that it's x, y, width, and height, right? I guess. Okay. Maybe the only thing that we need to keep in mind is how can we sync the canvas width and the canvas height with the C code, and maybe we need something like get the width and height or something, but shouldn't matter right now. So if we go to main, we should be able to define these functions. So void clear canvas and draw rect. Void draw rect is gonna be int x, int y, int width, int height, and there's that. Should I have extern keyword? So I can clear the canvas and then maybe draw rect 0, 0, 100 by 100. Now the only thing with draw rect is what's going to be the color, right? So we need to say things like fill style, whatnot. Maybe I need to, think about this part. How do I set the color? But yeah, if I refresh the page, you can see it's yeah, 100 by 100 in this canvas, which is pretty nice. Okay, so let's go back to main.c and let's define ds da implementation. Now the only thing why I think this won't work is because I'm using qsort in one of these. So yeah, inside of ds.h. So, really need, so if we have dynamic array, I mean, yeah, I guess sort makes sense, right? Being able to call sort, but we need, we would need some kind of function here maybe that's used to do the sorting. Right? I think the easiest way to get rid of that error though is to do something like qsort, and it doesn't even matter what the implementation is, or does it? It still doesn't like that because it needs to be defined, right? So I would need to do here qsort, and I think the types are conflicting, obviously. Now the only thing I'm thinking about is maybe calling here something like ds sort, the same way we do with ds malloc and whatnot, like ds string length, right? And have here ds sort or ds qsort or whatever. And now it's a different story here. We need to go back to ds string length, for instance, right? And we need something like this but for sorting. So I could just do ds sort, and then the ds sort macro is used to sort an array. Pretty simple. So if it's defined, it's okay. If defined, oops. If there's no std lib is not defined, then we just define this sort as qsort. So like items found size compare is going to be qsort count size compare. And I guess that if this thing is not defined, well, if we are trying to not use stdlib, we need to define it somehow. So we have elif, wait 1 second. So it's if this thing is defined, it's okay. If this thing is not defined, then we define it. Then we have another elif. Why is it broken? I don't think it's broken. So yeah. And for the last one, let's think about it. So if it's not defined, then we somehow need like an external sorting. Because I don't want to say null and then it's not gonna sort. That's gonna that's gonna be pretty weird. But I mean, we could do bubble sort just for the memes. I'm just trying to look at the other ones. I mean, they're just, yeah, like it is what it is, moments. Yeah, honestly, could just do bubble sort. Why not? Let's see if bubble sort, if Copilot will know how to define bubble sort. Well, actually, yeah, that's true. That's how it's implemented. Right? We have two for loops. Then we compare the element at j with j plus 1, I guess. And I mean, it's kind of hard to do it like this, I guess. Because you need to allocate memory, right? To be able to swap. Pretty sure you need memory to be able to swap. Yeah, you need some temporary memory. Okay, then maybe sort also needs the allocator. Right, it makes sense. But it's still doing this stupid mem copy. I like that. I feel like it sucks. So let's maybe just define a function like this where we are going to do the bubble sort, because that's kind of cringe. honestly. So static inline wait, qsort, is it I'm not sure. I mean, I'm not sure it matters, honestly, so it can be just void. Bubble sort, right? And we need the allocator, we need the items. Let's do allocator void pointer items unsigned long count, unsigned long size, and then the compare function. That looks good, but it's not the allocator. It's not bubble sort. What the fuck? Okay, whatever. Let me do the sorting because. Okay, so usually when I do sort with two for loops, like the lame sort, let me call it lame sort, I'm doing something like we go from I. Let me just see qsort. It's base size t compare function, and it returns void. Okay, so it's the definition is good. So when I do sort, I just start from 0, I go to n, and then I start at I, maybe I plus 1, right? And I go until count, yeah, makes sense, until count. Maybe this one should be count minus 1, though. Okay, then I compare items plus I times size, right? That's right. Then we allocate some memory with ds.malloc, which just gives me temporary place in memory. Then we copy into temp from here. Then we copy j over I, that's true. And then we copy temp over j. And then we read allocate the memory. So that's how I implement bubble sort. I don't know what the fuck was ChatGPT doing there, or I mean Copilot. But yeah. So if we have no stdlib and the sort is not defined, then we just create our bubble sort and then we call bubble sort instead. I think that's fine. So now it should pick up the new bubble sort implementation. Shit. Oh, that's what I say. Like, I don't know why my formatter for C wants to space, like that's crazy, you know. So let's see now that we have bubble sort instead. So now it's fine, right? And it still works. I even forgot what I was doing in here. So I was drawing a rectangle. So let's try now. Oh, so we have the dynamic array. Let's stop Copilot because I don't need it anymore. So ds dynamic array. Let's have an array. So we initialize an array. Maybe we can have some kind of structure, like rectangles. So type def struct rect t. or rect, and then I say rect t here. And this one is going to be int x, y with height. All right, and here let's do size of rect t. Okay, so we have an array of rectangles. Let's create some random rectangles. No, like extern width. No. Maybe I want to have a prefix for like I don't know, WASM or JS, like JavaScript. I don't know what the convention would be for something like this. JS width, JS height, right? Maybe another one would be extern JS random, and I give it like min and max, or int a and b, like a random number between a and b, just so we can draw some rectangles, and that would be that. So let's define some more things here. So JS clear canvas, JS draw rect, JS width, I guess number, and it's just canvas width, and we have JS height. And obviously, we don't have random because we don't have stdlib, so we have to get random from JavaScript, I would say. You know, you can implement your own random, but why wouldn't we just use JavaScript for that? Of course, you could also say the same thing for sorting, and you can actually do that. Like I could do here like define ds sort, right, and define it with some kind of function and then make it external. So yeah, how do I JavaScript random number math random, and this is a number between 0 and 1, and to get it between a and b I have to multiply the number with shit. I have to get a number from 0, 1 to get it between a and b. How the fuck do I do that? That's crazy. I have to multiply it with the difference and add a. I think that's the easiest way. Is it? B minus a plus a? Hopefully. Of course, I have to return it. All right, so we have that. Then we can say I want to function void rect random is going to get int width int height, and it's going to return a rect. So what I would say here is we want to compute the width and the height first, right? So I can do something like just random 0 width in height is just random 0 height, and then x is going to be just random 0 width minus w, and y is going to be just random height minus h, right? So that's gonna make it fit on the screen, I guess. And then rect dot w height rect dot y is y. Okay. Oh, and I mean I need to use arrows. Okay, fair enough. So that's how I'm gonna create a random rectangle. Okay, and we can add some for I is less than, let's say, 10 rectangles, I plus plus. Let's make it 0. Can say something like rect random with just width just height, and then reference to rect. Wait, what? Didn't I have the I? Okay, fair enough. And then I can say dynamic array append, and we are going to use our array and the rect. Sure, this thing can fail, but doesn't matter. Oh, here we have JS. Okay, so we created our rectangles, and then we can have for loop array.count, and we are going to ds dynamic array get, and for now let's just draw them, right? And maybe then we can also modify them, and get needs the index. Okay, and here we are going to say rect x, rect y, rect height. So this should draw the random rectangles. Still compiles. Index is out of bounds. I guess we need more memory, right? Let's do times 16 or something. Really? It's not enough? Times 16 again? Hmm. Oh, dynamic array init, init allocator. I forgot to pass in the allocator. But yeah, it should still have used the allocator. Let me just try to allocate some memory. Just like that. So it's still in dynamic array append. I mean, the dynamic array has, oh, it's so big. Let's do index and let's maybe put this amount times 16. Like if that's not enough, I don't know what's gonna be enough. Okay, so now it actually did something, but I don't see the, oh, bad memory. What does it mean? Bad memory initial size. The fuck? I mean, I'm pretty sure that this is the number of bytes, right? So if I say this many times 8, which is the size of an integer, it's not enough, right? I have to do something like plus 1024 something for some extra bytes. But now it says bad memory initial size. Pretty interesting. I mean, we could just say something like define ds shut ds the unit capacity, and let's make it like 120, like 8 or 16, I don't know. And maybe we don't need that much. Okay, so yeah, it's strange. You cannot put that much memory, that's weird. But anyway, so just draw rect, and maybe what I want to do is to also pass in the color somehow. So just draw rect with a color. So color, right? And can we 0x 1 2, yeah, we can have hexadecimal. Nice. Red, green, blue. Okay, so if we go into index.ts, we can have here color is a number. Now the question is field style. So JavaScript canvas field style hex. Okay, so it needs it like that. RGB. Let's see if Copilot knows. I mean, it makes sense. That would have been an easy way to do it. Oh, yuck. But I also want the color to be random, honestly. That would be pretty nice. So let's do just JS random between 0 and FFFF, yeah. So now we get some random rectangles. That's kind of cool. You know, maybe they're really big, so I don't want to have them that big. So let's divide by 8 or something. I don't think I need to run build every time. So this would be smaller rectangles. Maybe even like doing times 4, and the minimum width could be width divided by 8 and height divided by 8, like maybe, yeah, I guess. All right. Oh, so I need to run build. Ew. Okay, whatever. So that would be that, right? And there is this warning, obviously, that ds exit is not defined, blah blah, whatever. Maybe we could use multiple data structures and just to see if all of them work. For instance, some things that won't work are gonna be the debug logs, right? Because fprintf is not defined. So this is like if fprintf is not defined, then we just define it as 0. So obviously this would be something that we could make work with console log somehow, maybe. But we have to see. Anyway, let's do some more stuff with this thing. So now that we get that, maybe we want to have like type def start this. Let's do this is going to be a rect, maybe int color, and would be cool to have something like int vx, vy, like velocity, piece t. So let's create a function that creates piece random. Let's just, take it like that. Maybe the velocity is going to be negative 10, 10. Okay, makes sense. And here we have draw rect. That's perfect. So instead of an array of piece of rect, let's do array of piece. Oops, piece. And here let's create some pieces, just like that. Okay, and we append it. Then we might want something like while one, while true. We clear the canvas, and then we iterate all the pieces. So we have the entry point, like the main function. We create an allocator, we create a dynamic array, we append some stuff in the dynamic array which requires allocations. That's what the allocator is for. Then we have clear canvas, we iterate the array, we have piece t piece, we take, now is the fun part. So let's have a pointer actually, and let's do dynamic array get ref, because we want a reference, and we are going to pass it like this. So we take a reference to piece so we can change it, right? And here we can do piece dot rect and whatnot. So what's okay, whatever, it can handle it. So it draws the piece, right? It should be the same thing, but again I have to recompile it, which is weird. It stopped working. Oh no. Let's not do while one then, maybe. It died, of course. But then how do I well, I mean, we could check how I was doing it in the JavaScript version. So I was calling to render world, and I guess how this one worked, render world, yeah, I was kind of by, this one wasn't even doing that, but I guess let me do WASM Game of Life. That was the other one that I did. I think this one was in Rust. Interesting. Where is index.ts? Interesting. So this one was actually, pretty sure this one was using like a loop. Start. I don't know. But because this one was written in Rust, it's a bit different. But that's interesting, honestly. How can I? So world, render world, right? Render world. I mean, for this one was pretty simple because it wasn't like it was just one call. You didn't have to do any while loops. This one was also like that. I mean, Tetris bits C was a bit so the web one, right? This one needed this kind of render function, and I guess it's using request animation frame, right? And it was calling to render. So I might need somehow a function like request animation frame. Mm. Yeah, like maybe the entry point, and then I would need two different functions in here. One would be setup and one would be update, right? Maybe that's a better way to approach this thing. And then the allocator would be a global variable. I mean, even the array needs to be a global variable at that point. All right. And then this part could be inside of a different function. So let's call this one like init, and this one would be tick or something. All right. So we call init with the memory and whatever. We initialize the stuff, and then inside of tick we draw. So then where is the, this could be init function, and then tick function. I mean, for now it's gonna be empty. Maybe I want to pass in the delta time, right? dt delta time, or should I say delta time like that? It's like the delta time, and then this would be init function, and then we have the tick function. And this one was function game. I mean, I can just copy paste it, right? So the game loop, define this function, it requests an animation frame to itself, it takes the date, then I guess then is okay. Let's just have these variables. FPS is equal to 5 60 FPS. Okay, fair enough. So if it's longer, then we just need to call tick, but we don't need any of this stuff. And I need to pass in what? Elapsed? So it's like now minus then. Or I guess let's put it here just to have it one after the other. So we have the minus then. If it's longer than that, then we just go ahead. Okay. I mean, I don't need tick, but whatever it is, it's fine. Oh, and yeah, we could also have a try catch, I guess. So let's see if now it likes it. So now it's going to draw it frame by frame, right? So we might be able to actually update the velocities. Huh, not really. See, and here would be nice to be able to do something like ds log info and say something like piece, and then yeah, but doesn't, it's like really, you know, will be pretty hard. But that's interesting. Why doesn't piece color? Let's change the color. Oh, I didn't recompile it, right? Oh my god, yeah, sorry for whoever got, oh no. But they all disappear, right? So I would also say that tick needs a float delta time times delta time. Oops. But now it's an interesting question is some of them are like, oh what? Wait, why do they stay on the screen? That's kind of weird. What? I'm curious how okay, so elapsed is like the number of milliseconds. Then it's fine. Then it's fine. So the speed is between minus 10 and 10. That makes sense. But you know, it's like, why doesn't it go out of scope? Like out of bounds, I mean. Is because it's being changed. So this one is an integer, right? This one is also integer. What? I'm like, what? How can the delta time be? Like, that's pretty interesting. Whatever. I mean, let's say that it's in milliseconds or something. I don't know. And now we can make the speeds a bit smaller. Ah, but now it's... Okay, I see. Let me just divide this by 100. And let's make these floats. And I have to do... Let's make the speed floats between -1 and 1. Like that. It's still kind of fast. Maybe I have to divide by 10 again or something. Okay, so it goes out of bounds, but yeah, I mean, whatever. Actually, let's keep it normal speed. Okay, yeah, fair enough. But let's make it now bounce, right? So if the piece, something like that, I guess, and we need the y as well. I don't know. Let's see if ChatGPT actually managed to nail that. I guess it did. So it did what? If the piece y position is lower than 0, or piece y plus height is greater than height, then we swap the speed. Okay, yeah. And then it needs to go back. Maybe we can avoid this part. Can I say something like, if wait, but I don't think that works. I mean, still the same thing. So yeah, pretty interesting. Now it works. So yeah, we were actually able to use the allocator. I mean, we did kind of something similar to this a while back, but now we have a better allocator. Like, it actually lets you use malloc and stuff like that, which is kind of neat. The only weird thing was that I couldn't put more memory in WebAssembly. It complains about that. I don't know why. It's kind of strange. And yeah, the other things that would be nice would be these log messages, but I think that's pretty difficult to do. I'm curious about the string slice. Let's see if I compile with string slice enabled, if it's going to die. Let's see if it okay, so string slice seems like it compiles, right? Let's see string buffer, or maybe so like that. Data structure da string. Oh, so string it's like this. Okay, so it needs some functions. Oh, it has those VA thingies. VNS printf. So with the variadics, I mean, is space. It's probably a pretty simple one, but these ones, yeah, the variadics arguments. Okay, so string stuff would be kind of weird. Let's see the priority queue. Curious. Priority queue would work, obviously, that's pretty simple. Linked list, is it? Linked lists would also work. And hash map is the last one. Okay. Obviously, IO doesn't make sense. Like you cannot have files, right? And the other one that wouldn't make sense is the argument parser, but where is the whatever? It obviously doesn't make sense to have argument parser. I'm curious about if we would use arena allocator. Oh, and you know what was my mistake here? I should use the allocator like this. ds allocator init. Wait. Init allocator. Right. And now we can just swap between the two allocators without any issues, hopefully. Let's see. So this is using the arena allocator, and if I change this to list allocator, it's going to just use the list allocator. But I have to compare it. I think this still works, which is kind of cool. Yeah, so maybe the string stuff would be interesting to make work. And the other stuff that I think would be interesting is logging. So obviously, if let's say that I do one log here, so I do something else. This log info. Like how can you actually implement that? So if I need to define fprintf beforehand. Yeah, that's a good point. Like, how can I make it such that it's, because if you think about it, if I don't define fprintf, I don't want to not be able to compile. I just don't want to enable logs, right? Like, I don't really care that it's not defined. Because what I could do is maybe something like extern int js fprintf, but the problem is what are going to be the arguments. And then I can define fprintf as jsprintf, right? But it needs the stream, it needs format, it needs a bunch of stuff. I mean, the stream is simple. It's can I just fprintf? So it needs a pointer, const char pointer, so 2 pointers. First one is like a number, doesn't really matter, and then it's like stuff. So it can be like void pointer stream format, and then like, how do you do that in JavaScript? Right. Is that a thing you can do in JS? JS fprintf string number format has to be a number, but then how can you do variadics? I don't think it's possible. At least you could console log the string like this. Oh, how did I take the buffer? Like this. Pretty nice. Like, it, at least it prints the format string, but I don't know how I can take the variadics. And then inside of main.c there is another thingy that we could enable, and that's no terminal colors, because we cannot have terminal colors. Right, so it looks a bit better, but it's still bad. Is that a thing? I don't think so. Rest parameters. Ooh, dargs. So there is something like that. And that's gonna be interesting because the rest of the arguments really depends on what you do here. Let's see if interesting. Whoa. I mean, come on, let's not go that far. Console. Let's see if it can replace. I mean, it would be interesting to. Okay. Okay. Let's just say we are going to print it like this. Also, it actually. Oh. Also, it is like C almost in a way. You know, the only problem. Hmm. The only problem is. Okay, so those are passed maybe as pointers. So maybe these are all numbers and they are converted into number. Like const values. Maybe I want to. Like this looks stupid. I mean, I have the memory. I was gonna say something like memory. No. Memory at arg or something. But I don't know. Oh, that's closer. So maybe it does look like it's no, it doesn't work. Yeah, I don't know. That would be an interesting thing to try and figure out how we could have logs in C that would be printed to the like console log, you know, the console in browser. That would be kind of cool, not gonna lie. but I would have to look more into it. So yeah, I guess that would be all for today. We're able to use our ds.h pretty much with all the features like the allocator, dynamic array, which is the most important one, and we were able to draw some random rectangles moving. It's kind of nice. And yeah, I'd say this was pretty nice, refresher for how to use WASM with TypeScript MC, which pretty nice. So yeah, hopefully you found this one interesting, and let's see in the next one. So see you.